All right, quarter 3 notes. So there's going to be a couple questions on some first 9-week material. So this is basically just reviewing what we learned in the first and second 9 weeks. So first thing is ordering numbers. So putting numbers in order either from least to greatest or greatest to least. So first thing is let's make sure we understand some vocabulary. What does descending mean? Getting smaller. So that would be greatest to least. And so ascending would be getting bigger. So that would be least to greatest. Okay. So if you know that, obviously you don't have to write that down, but just wanted to make sure we have that vocabulary. So anytime you're looking at numbers and you're wanting to compare them, I always want to make sure they're in the same format. Good morning. So what format do we usually prefer them all to be in? Decimals, yes. So how would I change this fraction 4/3 into a decimal? Divide it, right? Divide the numerator divided by the denominator. So 4 divided by 3 would be 1.3 repeating. Okay. Square root of 15 over 4. Everyone go ahead and open Desmos and make sure you can figure this decimal out. Because if you just can only wait on me, oh, Miss Patterson will do that. She'll give me the answer, blah, blah, blah. Then when it comes to the actual test, you're like, how do I put this in Desmos? Wait a minute. Let me go ahead and share Desmos screen so we all can. So go ahead and you try it first. The square root of 15 over 4. The square root of 15 over 4. And if you don't have your iPad, you have a you can just look up Desmos on your phone. You don't have to have your iPad. Bless you. So the square root of 15 over 4, it looks like this on the PowerPoint. Square root of 15 over 4. So when I do that, square root of 15, if you notice, if from here you just press divided by 4, that square root symbol is on the whole entire thing. We don't want it on the whole entire thing. We only wanted the square root symbol on the 15. So when you have the square root of 15, you need to make sure you press to the side of it and then divide it by 4. Now it looks exactly like the problem that we're just looking at. So was that 0.968? Okay, I'm trying to remember that. All right, so 0.968. So that's what you should get for that. All right, I have 150%. How do I change a percent into a decimal? Move the decimal 2 spaces to the what? Left, yes. And if you remember in Miss Weekman's class, DP, percent to decimal, move it 2 places to the left, yes. So 150%, the decimal's at the end. We'll go 1, 2, that would be 1.50. And then 1.45 is already in decimal format. So if I wanted to put these in descending order, can someone tell me what the first number would be? If I want to put these in descending order, what would my first number be? 1.5, absolutely. And we know that because even though some people are like, well, how do you figure that out? These have ones in the tens place. So the next place I look as the tenths place. So there's a 4, a 5, and a 3. 5 is the biggest. So this would be my first one. All right, what will come next? 1.45, awesome. Next, 1.3 repeating, and then obviously the 0.968. Good. Okay, everyone feel okay about doing that yourself. Now, I will show you later on in the year how to actually do this in Desmos, where it'll give you the actual answer all the way through, but I'm not going to do that now. I'll do that later on towards when we review for STAR. All right, scientific notation. Who remembers this? Ooh. So A times 10 to the power of B. If you don't have any notes, we did scientific notation when everyone was virtual. So I already know some people take notes over this. So if you don't have them, make sure you get those, okay? So scientific notation is where we write really big numbers or really small numbers. So A times 10 to the power of B is the format of scientific notation. A is any number between 1 and 10. And B is any integer. So 2,050,000. I want to write this in scientific notation. Right now, the decimal is at the end of the number. Where would I need to move the decimal so that this number would be between 1 and 10? Between the 2 and the 0. And remember, the fast way to know that is there's always going to be one digit in front of the decimal. Always one digit in front of the decimal. So my new number would turn into 2.05. And I don't need to write all these zeros. Now, 2,050,000. That number is greater than 1. So that tells me my B is going to be positive. So if my number is greater than 1, then B is positive. If my number is less than 1, then B is negative. So 2.05 times 10 to the power of, how do I figure out what that B is? Absolutely. How many spaces did I move the decimal place? So I moved it 1, 2, 3, 4, 5, 6. So I moved my decimal place 6 times. So 2.05 times 10 to the power of 6 would be this number written in scientific notation. I can already tell Allie's a G at this. She remembered this, how to do this, okay? If you did not remember this, that's fine. Let me show you how you can check your answer in Desmos. So I'm gonna keep going back and forth. Thanks. So the answer that we got was 2.05 times 10 to the power of 6. Well, I can put that into Desmos. 2.05 times 10 to the power of 6. Well, what number did that give me? 2,050,000. There's my original number. So you can always go back, put the number that you got in scientific notation, and see if it matches with the original number that's in standard form. Okay, this is your review. It's on you to actually be listening and paying attention. So that was standard to scientific? Yes, that was standard to scientific. Okay, 0.0025. I'm going to put that in scientific notation. The decimal is right here. Other than Allie, where would I need to move my decimal so that my A is between 1 and 10? Behind the 2. So between the 2 and the 5. Because that would make the number 2.5. Remember, there's only one number in front of the decimal place. So 2.5 times 10 to the power of, is my B going to be positive or negative? Negative, because 0.0025 is less than 1. And how many places did I move my decimal? 3. So to be to the power of -3. Again, I can go check that answer in Desmos. (2.5) times 10 to the power of -3. And there's my number, 0.0025. Okay, so you have resources, use them. Desmos is a great resource. All right.
Miss Patterson.
Yes, Kayla Kang.
You can't really go backwards. So what you did is you found you had the scientific notation and then you put it into long form in Desmos. Can you do the opposite?
Like, can you put like this number into Desmos and it give you the scientific notation for it?
Yeah.
No, it won't do. It won't do that for you. Unfortunately, that would be nice because it would just give you the answer. So let's say that it gave me the scientific notation format and it wanted it in standard form. Now you could just put these into Desmos and figure out what it is, or if your B is positive, it's telling you to move the decimal to the right. If your B is negative, it's telling you to move the decimal to the left. So 4.07 times 10 to the power of 2, that positive 2 is telling me to move my decimal place to the right 2 places. So 1, 2. So that answer is 407 in standard form. So this is scientific to standard. All right, 2.3 times 10 to the negative 4. What's this negative 4 telling me to do? Perfect. 4 places to the left. So 1, 2, 3, 4. And what am I filling in all these blank spots with? Zeros. So it'd be 0.00023. Now I'm going quick because this is just supposed to be review. It's not supposed to be me teaching it, reteaching it to you. All right. Last thing we're going to talk about is transformations. Yes, this will be tested again on the Q3. So if you forgot all about translations, reflections, rotations, dilations, listen up. So if I'm going to the right, so remember here's a graph, x-axis, y-axis. If I'm going to the right, which axis is that on, X or Y? X. And if I'm going to the right, is that increasing or decreasing? So if I'm going to the right, that's adding to the X. So I would add whatever that is to the X. If I'm going to the left, this is also on the X-axis, but I'm decreasing along my number line. So that would be subtracting from the X, subtracting from the X. If I'm going down, is that X or Y? And am I adding or subtracting? Subtracting. If I'm going down my line, I would be decreasing on my number line. So that would be subtracting from the Y. And if I'm going up, that's the Y, and I'm increasing on my Y. So if I was going 3 units to the right and 4 units down, everyone write what that algebraic representation would look like. Go ahead and write it down. And I will, if you are in the classroom, I will call you out because I can obviously see if you're not even doing anything. If you're at home, I'm not going to call you out, especially if you're a first-time Zoomer. Welcome. But make sure you're also participating because this is your learning. I know my information. So if I'm going 3 units to the right and 4 units down, what would I write for my algebraic representation? And what I mean by algebraic representation, X plus A or Y minus B, it'd be some kind of numbers here. And whatever sign you're looking for to put in here. I'm not saying this has to do with this, but. So if I'm going 3 units to the right, is that X or Y? X. And would I be adding or subtracting? Adding. So that'd be X plus 3. If I'm going 4 units down, is that X or Y? Y, and am I adding or subtracting? Subtracting. So that'd be Y minus 4. And there would be my algebraic representation. All right, try that last one. We want to finish within the next 5 minutes. We can do this. So if I'm going 5 units up and 6 units right, go ahead and write that algebraic representation. Pay attention to the directions. Pay attention to which direction it's saying. All right, if I'm going 5 units up, 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 is that X or Y? Y. Am I adding or subtracting? Adding, so that'll be Y plus 5. But Y does not come first, so that still will be the second part. 6 units to the right, X or Y? X, adding or subtracting? Awesome, so it'll be X plus 6. X plus 6, Y plus 5. Ask me questions. I know I'm going fast, but this is just so we can get to the actual assignment today. Alrighty then. Reflection. Oh, quick question. Translation. Does it preserve congruence? Yes. So if I'm moving my pen isn't getting fatter or smaller. It stays the same. So it preserves congruence. All right, reflection. Remember, these are really memorization. So if I'm reflecting across the x-axis, so say I'm at a heart here and I reflected it across the x-axis, X stays the same, Y changes signs. So this does not mean Y is negative, it means Y changes signs. So X stays the same. Y changes signs. What are you going to be tested on? You're going to be tested on the rule. So this is something you have to memorize. If I reflect across the y-axis, Y stays the same, but X changes signs. Okay, so these are 2 rules you just have to memorize. Yes, ma'am.
What's a good way to remember which one it reflects on, which axis?
It would tell you which axis to reflect over. Are you talking about like how to memorize the rule?
Not the rule, like I just no, I don't know.
Okay, it will tell you, like on the test, it would be like, literally the question would be, what is the rule? What is the algebraic representation if I reflect this image across the x-axis? And you just have to know, okay, X stays the same, Y changes the same. So X negative Y. So if point A was at negative 2, 4, there, this is the X, this is the Y. What would A prime be if it was reflected across the x-axis? What would A prime be if it was reflected across the x-axis? So my rule for that is X negative Y. X stays the same, Y changes signs. So anyone bold enough to say what A prime would be? Say it a little louder, babe.
-2.
Negative 2, negative 4. Yes, and yes to my Zoomy. Yes, so A prime would be at negative 2, negative 4. Awesome. 1 minute. Okay, rotation. If you don't memorize these rules, take screenshots, take a thing. Or if you have the rules already written down, you're good then, okay? So this is literally just memorizing the rule. 90 degrees clockwise is Y negative X. Y stays the same, X changes signs, and then you flip X and Y. 180 degrees clockwise, counterclockwise, X and Y change signs. 90 degrees counterclockwise, Y changes signs, and you flip the X and Y. The way that I memorize it is I know that rotation is the only one where you flip X and Y. It's the only one that does that. Okay, so that's the only way that I memorize it.
Miss Patterson.
Okay.
Will we get to use our notes on the test?
On the 9 weeks test, no, unfortunately not.
Okay.
Yeah. So I mean, like I said, what I did like in previous years for STAR testing is like I would make note cards and just study. And I would stand at the door and be like, can't get in unless you remember the rule. And be like, I hate that. I'm like, oh well, figure it out. All right, so I'm not gonna do this problem for the sake of time. Last thing I wanna talk about is dilation. This is the last one we're doing. Dilation. Wait, real quick. Reflection, did it preserve congruence? Yes, when you look in the mirror, do you get fatter or skinnier? Unless it's a terrible mirror, but no, you should stay the same. So reflection, you stay the same. Rotation, if I was rotating right now, am I getting fatter or skinnier? No, it stays the same, so it preserves congruence. But dilation, does dilation stay the same? No, dilation is the only one that does not preserve congruence. Does not preserve congruence. This is the only one that does not preserve congruence. So for dilation, the algebraic rule is kx, ky, where I'm multiplying k to x and I'm multiplying k to y. This is the only one that multiplies, so that's another way to know whether or not it's dilation. K stands for scale factor. If my k is greater than 1, my thing got bigger. If my k is between 0 and 1, my thing got smaller. But how do I know which one my pre-image is and how do I know which one my image is? The prime notation, absolutely. So remember, your pre-image would have just A, B, and C. Your image, the one it's transformed into, would have the prime notation, A prime, B prime, and C prime. So here, you have this triangle and you have this triangle. This says A, this says A prime. So did it get bigger or did it get smaller? It got smaller, it reduced. So since it got smaller, you know your K value should be between 0 and 1. To figure out how much smaller it got, we do new over old, no. So I'm gonna do A prime over A. A prime is at 0, 4. A is at 0, 8. So divide it. What is 4 divided by 8? Four divided by 8? 4 divided by 8? No, why do y'all keep saying 2? What? No. No? What is 4 over 8? Use a calculator.
Oh.
1/2, yes. LOL, 0.5, thank you. Okay, 1/2. So my scale factor is 1/2. So xy to 0.5x, 0.5y would be the algebraic representation. If you don't know this stuff, you don't remember it, you don't feel confident, then take a screenshot, okay? That was so much. Oh my goodness.